Okay, today's lesson is topic 10-3, trapezoids. So we're still investigating our properties of the different quadrilaterals. So remember that parallelograms have these 5 basic properties. We have both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, the diagonals bisect each other, and any 2 adjacent angles are supplementary. So you might practice putting in your other check marks for the other figures, because remember that rectangles have all 90-degree angles. And so that would be something extra you would check on the rectangle. And a rhombus has diagonals that are perpendicular. And the rectangle has diagonals that are congruent. And the square is both a rectangle and a rhombus, and so whatever you check for the rectangle, you should check for the square as well, etc. Okay? And the kite, etc. So make sure you're checking all your properties onto your fact sheet. Okay, and you have your flowchart that will help you out as well. All right, so last we're going to look at trapezoids. Remember, by definition, a trapezoid is a quadrilateral with one pair of parallel sides. So let's look at this trapezoid ABCD. And first we have example 1 says if the measure of angle DAB is 128 degrees, so that's this angle here, then the measure of angle ADC should be what? Well, since the AB and DC are parallel lines, the bases, and this side of the trapezoid could be the transversal, then those would be same side interior angles. So 180 minus 128 would leave us with 52 by same side interior angles theorem. Okay? All right, then if the measure of angle AEB is 121, that would be this one. And what's the measure of angle DEC? Well, those are vertical angles, so that should also be 121. All right, what about the length of AC? How can we find the length of AC? Well, let's make this into a right triangle, and one side is 4 and the other side is 7. So we would do, to get the length of AC, we would do 4 squared plus 7 squared and take the square root. So the length of AC is 16 plus 49, which is 52. So we get the square root of 52, or simplified would be 2 square root of 13. Okay? All right, and then let's find the length of DB. So we'll do the same thing. Here's DB. It's already in a right triangle for us. So this side is 4 and this side is 9, looks like. So 9 squared plus 4 squared, and take the square root. So 81 plus 16, and that would give us the square root of 97. So we can see here that the diagonals are not congruent. So this is a generic trapezoid. Diagonals are not congruent. What's the measure of angle ABC? Well, that's 90, right? Because you've got a horizontal and a vertical line. And then the measure of angle BCD is also 90 for the same reason, but also same side interior angles should add up to be 180. Okay? All right, now let's look more specifically at an isosceles trapezoid. So here's an isosceles trapezoid, and what is the length of DB here? So let's do the same thing and do your right triangle. And so DB, we have 4 squared plus 7 squared. Take the square root, so we get the square root of 65. And then AC, if you look at, make a triangle out of AC, it is going to be the same length. 4 and 7 are your side lengths, so you get square root of 65 for that as well. So in this case, if it is an isosceles trapezoid, then we know that by definition the legs are congruent, and this is another property, is the diagonals are congruent as well. Then if the measure of angle ADC is 54 degrees, then what's the measure of angle BCD? Well, on our fact sheet, by definition, the base angles are also congruent. So those are angles on the same base, so this should be 54 degrees. Then if angle ABC is 126, so if angle ABC is 126, that's this one, then what's the measure of angle DCB? And that would be this one. So again, these lines are parallel. The side BC is a transversal, so 180 minus 126 gives us 54 for that angle by same side interior angles theorem. Then example 4, if AD is 2.4 centimeters, so that's this side, then BC is also 2.4 centimeters. By definition, we know that the legs are congruent in an isosceles trapezoid. And then if the measure of angle AED is 60 degrees, that is this angle. What's the measure of angle CED? That's the one right next to it. So those are a linear pair, so 180 minus 60 is 120. And then the measure of angle BEC would also be 60 because those are vertical angles. So the isosceles trapezoid will have the properties of a trapezoid, but a lot of our other angle properties with parallel lines will come into play as well. All right, so make sure you go onto your fact sheet and check off those properties for trapezoid and isosceles trapezoid.